Previously, we looked at the types of events, and the first type of event that we discussed yesterday, previously, it was the independent events. And we said that if the events are independent, they have two special characteristics, that the A intersection B, that is the probability of event A and event B occurring at the same time, said it is the same as the product of their respective probabilities, respective chances. Then we also mentioned that for independent events, the probability of A union B, and union, we say that it is union A union B, means the chances of either event A taking place or event B taking place, or both events taking place at the same time. And for independent events, we say they divide as the probability of A plus probability of B, then minus probability of A times probability of B. That was for the events which are independent events. And still on independent events, we noted that if A is an independent event, then its complement is also independent. It's also independent. Also, if event B is independent, also its complement is independent. And we made a statement that the chances of A complement intersection B complement is the same as the probability of A complement times the probability of B complement. That if the events are independent, even their complements are independent. That's what we discussed about the independent events. Now there are these mutually exclusive events. Mutually exclusive events. And so the events which are mutually exclusive events, they do not have anything in common. Means that both of those events cannot happen at the same time. Another example of a mutually exclusive events, for example, in a mathematical experiment, if you toss a coin, you cannot have a head and a tail at the same time. Because when you toss, you can either get a head or you can get a tail. So these two events are mutually exclusive because they cannot occur at the same time. So also, if you are, for example, in a race and you are running, you cannot run forward and run backwards at the same time. So those running forward and running backwards are mutually exclusive events because they cannot happen at the same time. So mutually exclusive events, these are events which do not have anything in common. And if events A and B are mutually exclusive events, then their intersection is an empty set. That is the number of elements in set A intersection set B is an empty set. There is no member, there is nothing in common. It means that they don't share anything. So here the probability of event A taking place and event B taking place is equal to 0 because those two events, they don't have anything in common. So that is independent events. The two sets, the set A and the set B, if they are independent events, if they are independent, they are mutually exclusive sets, means that they can be represented on a Venn diagram and they are represented as disjoint sets. They cannot intersect because if you draw a set A intersecting set B, means that they have members there in common. But these two sets are disjoint sets because they cannot intersect. They don't have members in their intersection. They don't have their intersection is an empty set. So when you're representing the sets A and B, which are mutually exclusive sets, they are represented as disjoint sets. So set A and set B are disjoint sets. And for mutually exclusive events, there are two special things that we cannot hear about the mutually exclusive events. That if events A and B are mutually exclusive events, A and B are mutually exclusive events, then the probability of A intersection B is 0. Meaning that the chance of A and the chance of B happening at the same time, that's the middle of the intersection. The chance of A taking place and B taking place at the same time is 0. Like as we said, you cannot run forward and backwards at the same time. So means that that is the meaning of the intersection. Two things happening at the same time. So the intersection there is 0. Then we said from the definition of the union that A union B for a mutually exclusive event is the same as probability of A plus probability of B minus probability of A intersection B. This is the general definition of the union of events. But for mutually exclusive events, we say that the A and B is 0, means that those two cannot happen at the same one at the same time. So if you substitute the 0 here, if you substitute the 0 here, where there is the intersection, so remember the A union B is equal to the same as A plus B minus 0. The probability of A union B, because we say that the union, it means the chances of either event A taking place or event B taking place, either event A taking place or event B taking place, or both of them taking place at the same time. That is the union. That since the chances of both taking place at the same time is 0, it means that the probability of A union B is the same as the probability of A plus the probability of B. From this statement here, where there is the probability of A union B equals to A plus B minus A, but the intersection is 0. So means that the probability of A union B is the same as A plus B. So this is very special for mutually exclusive events, and these characteristics they only work for mutually exclusive events. They cannot be mixed for other kinds of events. So also we say that when you add the chances of A happening plus the chances of A not happening, you get 1. The chances of event B taking place and the chances of event B not taking place, when you add them, still get 1. So also these principles, they hold for also mutually exclusive events. So here there is an example. Here there is an example about the mutually exclusive. They say that if A and B are mutually exclusive events, such that the probability of A union B is 0.8 and the probability of A is 0.4, find the probability of B. The probability of A union B is equal to 0.8 and the probability of A was given as 0.4. So from the definition of the mutually exclusive events, we say that the probability of A union B is the same as the probability of A plus probability of B minus the probability of A intersection B. But the intersection of mutually exclusive events is 0. So meaning that the probability of A union B is equal to probability of A plus probability of B minus 0. So it remains probability of A. And this one here we have it as 0.8 is equal to probability of A, which is 0.4 plus probability of B. So if we move the 0.4 on this side, we have 0.8 minus 0.4. So you remain with the probability of B as 0.4. So we shall look at more examples about the mutually exclusive events as we are proceeding. But for now, we need to first look the basic characteristics of two events which are mutually exclusive. Even when there are 3 mutually exclusive events, for example, the probability, if they are mutually exclusive events, A and B and C are mutually exclusive events, then the A intersection B intersection C must be equal to 0. Must be equal to 0. That is for mutually exclusive. They don't have anything in common, whether it is 1 event or 2 events or 3 events, their intersection is 0. So that is about the mutually exclusive events. So there are these other types of events. After looking at the mutually exclusive events and the independent events, there are also these types of events which are the exhaustive events. The exhaustive events, they have two special characteristics: that if two events are exhaustive, when you add their respective chances of happening, like the chance of event A taking place plus the event of B taking place, when you add them, get one. You add one. Also, another special characteristic also for exhaustive events, that the chances of A taking place and the chances of B taking place at the same time is zero. Means that also the mutually exclusive events, they do not have anything in common. But what separates them from the mutually exclusive events, that for them, when you add the probabilities, the respective probabilities, probability of event A and probability of event B taking place, you get one. So these are two special characteristics which we shall be using to solve almost all the problems which are related to exhaustive events. When you add their respective probabilities, you get one. The chances of A and the chances of B taking place at the same time is zero. And these characteristics, they only work if there has been clearly mentioned that the events we are dealing with are exhaustive events. Then there is this example that events A and B are exhaustive events such that the chances of A taking place equals 0.6. What regards to find the probability of B. Probability of B taking place and the probability of A and B taking place at the same time, or A or B or both of them taking place at the same time, and that is the union of those events. So if we come to our solution here, we have the probability of A is equal to 0.6, but since it has been clearly mentioned that these two events are exhaustive events, meaning that the chance of event A taking place plus the chance of event B taking place should give us 1. So if you have A as 0.6 plus the chance of B taking place, must give us 1. So you have the probability of B is equal to 1 minus 0.6, and this one gives us 0.4, meaning that the chances of event B taking place is 0.4. Is 0.4. Then this one here, question 2, the probability of A union B is the same as the probability of A plus probability of B minus the probability of A intersection B. But remember, for excessive events, the A intersection B is equal to 0. Is equal to 0. Meaning that the probability of A union B is equal to probability of A plus probability of B minus 0, so it remains A plus B. So the union A union B here will equal to 0.4 plus 0.6, and everything gives us 1. So for exhaustive events, their union is the summation of the individual probabilities of the events. So that is about the mutual, the exhaustive events, and we shall state more examples on mutually exclusive events, exhaustive events, and independent events after looking at the laws of probability. So those are the sum of the types of events which we look at the discussion of the probability theorem at this level.